Hey everyone, I am Miss Hu, your physics teacher. In this video lesson, we're going to be learning about errors in terms of systematic and random errors, as well as compare precision and accuracy. Now, this is going to be quite a simple introductory video about these concepts, suitable for students who just need to know this information for their examinations. But if you'd like to understand more about these concepts, just let me know in the comments below and I'll make more detailed videos explaining these. For now, let's just go into an understanding of errors. So when we say errors, what do we mean? Most students, when they hear the word error, they think, oh, mistake, because yes, that's what error means in English. But remember that in physics, we have terms that have very specific meanings. These kind of words, also known as jargon, are unique to every single industry. So in physics, we do take words from English that sound like English, spell like English, we even pronounce them, and we use them in a similar context, but they have very specific meaning. So although, yes, in the English language, the word error means mistake, in a context of physics, error refers to the difference between a measured value and the true value of a physical quantity. So errors are not about making mistakes, but rather are due to limitations of instruments and experimental procedure. So what this means is that if you were to take a measurement, there's of course a true value, but the reality is, and you should know this based on real life experience, when we take measurements, we don't always necessarily get the true accurate value. Sometimes there could be a difference between the value that we measure against the actual value. And what causes that difference? That's known as an error. Generally, errors can be categorized into two types. There's systematic errors and random errors. Systematic error is an imperfection in the equipment that causes an error in the measurement, while a random error is a type of error in a measurement or observation that fluctuates unpredictably, affecting results in a seemingly random way. Let me elaborate on this just a little bit. So, systematic errors are imperfections in the equipment that causes an error in the measurement. So, looking at the term systematic, what does the term systematic mean? Very structured, right? So you can think of it as it's very systematic in the way that they appear. So systematic errors occur in every measurement or reading taken. So the reason why this happens is because the equipment itself has that imperfection. So if you use that equipment to take a measurement, every measurement you take is going to have an error. Because of this, systematic errors cannot be reduced by taking repeated readings. And because of the equipment error, values tend to be shifted in the same direction. Examples of systematic errors are zero errors and calibration error. Now, what is a zero error? Now, zero error doesn't mean no error, like, oh, zero does not exist. That's not it. A zero error is an error in the measuring device that shows a value when it's supposed to be zero. So, for example, a weighing scale. Now, I'm sure that some of you may have experienced this before. You step on a weighing scale and suddenly say, oh my god, I gained an extra 1 kilogram. Then when you step off, you're like, oh, no wonder. The reading already started from 1 kg. So of course it's going to add 1 kg to my measurement, right? If the scale shows 1 kg when it's supposed to be 0, that's a zero error. So any equipment that shows a non-zero value when it's supposed to be 0, that is a zero error. Every measurement you take will of course have these additional values added on to your measurements. You can repeat it as much as you like, but it's still going to have the same error, and all the values tend to shift towards that same direction, meaning it adds on that extra value. So remember that zero error doesn't always necessarily have to be a positive error. There can also be a negative zero error where the reading shows less than 0. The second type of systematic error that may occur could be a calibration error, which means that there is a problem with the scale on the measuring instrument. For example, the scale on the measuring instrument is incorrect to begin with. Some of you may have experienced this before. If you get a ruler where the scale on the ruler is wrong in the first place. So this happened to me when I was in school. I bought myself a brand new ruler. Every time I took a reading with that ruler and I compared my values against my friends, I was always the odd one out. Everyone else would get a similar value, but I was like way off. And it made me doubt myself. Oh my gosh, do I not even know how to use a ruler? And finally I realized, wait a minute, I took my ruler, lined it up against my friend's ruler, and the scale was completely wrong. Needless to say, even though the ruler was brand new, I threw it away because what's the point of having a ruler where the scale is wrong? Of course, I know I could have just used it to draw lines, but you know, the ruler's only as good as its scale, right? So again, because it was a problem with the scale, every reading I take had that error. I could have repeated the reading as much as I like. The error would still be present. The values tend to shift in the same way. So if let's say the scale was too small, all the readings would be too small. Or if the scale was too large, then all the readings would become too large. So to remember systematic errors, just remember systematic means it's very structured, it occurs very systematically, has to be a fault within the equipment. Now the other type of error, which is random error, is, as the name implies, it's very random. So this error fluctuates unpredictably, so the results are affected in a rather random way. So random errors are opposite to systematic errors. This type of error does not occur in every measurement or reading taken. So sometimes it occurs, sometimes it doesn't, and because of that, random errors can be detected or reduced by taking repeated readings. Examples of random errors could include parallax error. So parallax error is when you place your eye in the wrong position. Instead of looking at the scale straight on, you're looking at it from different sides, causing the readings to increase or decrease. So depending on where your eye position is, the error could exist or not exist and can shift in different ways. So that's why it's a random error. Human reaction time is also a random error. So an example of when human reaction time error could occur would be handling a stopwatch. So when we press a stopwatch, of course, we're responding to what we see. When we press start or stop, it depends on our response to what we observe. Obviously, human beings, we can't start and stop at exactly the correct point. So sometimes we may start a little too early or a little too late. The difference in time may be minuscule, but it is still a factor in this case. So that's why human reaction time is considered to be a random error. Environmental factors depend on the situation at that point in time. For example, if you're measuring the time of oscillation of a pendulum, let's say if there's a wind factor that wasn't taken into account, causing the swing of the pendulum to be slightly affected. That's one example of an environmental factor. Or if let's say you were trying to measure the time it takes for hot water to cool down, it does depend on the room temperature surrounding that hot water as well. So some of these errors could affect our readings, but they can affect them in different ways. That's why they are classified as random errors. Now, let's compare precision and accuracy. So again, here are some jargon for physics, which are a little bit different from what you have learned in the English language. So a lot of people, when they use the term precision and accuracy, they tend to use them interchangeably because they appear to have the same meaning. However, in physics, the meanings are extremely different. So you have to be very careful about the term that you use, especially when it comes to your examinations or even writing your scientific report. So what are precision and accuracy? Results are precise when the measurements taken are close to each other. That means they have small deviations compared to each other, or they have a small range. Results are accurate when the measurements taken are close to the actual or true values. To help you understand the difference between precision and accuracy, let's take a look at this diagram. So one way to help you understand the difference between accuracy and precision is by using a bullseye dartboard like this. Now let's say the target here is the red bullseye. If we can get our dart to hit the center of the bullseye at the red center, that means we're very accurate in our throw. Let's look at the comparison between these four dartboard results. So on the top left here, we have a situation where the darts are scattered and they're not anywhere near the bullseye. So because they're not near the bullseye, they have low accuracy, and because they're so spread out, they have low precision. Now let's look at the diagram on the top right, which is diagram B. You can see in this diagram, the darts are not near the bullseye, meaning they have low accuracy, but they're very close to one another. So the deviation or the range between the darts is extremely small. You tend to keep throwing them to the same area over and over again. So the precision is very high. Now looking at the bottom right diagram, which is diagram C, you can see that some of the darts have managed to hit the center. So yes, they have high accuracy, but they are spread out, which means that they have low precision. If we look at diagram D, all the darts are able to hit the center and the range is very small. So diagram D shows an example of high accuracy, high precision. So take this analogy and apply it to measurements. So accuracy is when the readings that we take are very close to the actual value. High precision is when the readings we take are very close to one another. So low accuracy is when the readings are not near the true or actual value, and low precision is when the readings are too spread out from one another, meaning that the range is very large. And that's it for this video lesson. So if you found this video to be educational and helpful, do click like and let me know in the comments below how you have found this video to have helped you. If you'd like to help me keep making free educational video lessons and lab practicals, donations are welcomed at my Ko-fi page. That's ko-fi.com/physicsrocks. For notes, quizzes, and syllabus updates, check out my website at physicsrocks.com. Do watch my videos on other topics on my YouTube channel which you might find helpful. Subscribe for more free physics lessons from your physics teacher, Miss Ho. Happy studying!